I have more students now. 1, 2, 3, 4, 5, 6, 7, 8, 9. Nice. Okay. 10 students. Wow. Okay. To 5 of parentheses to third raised to the 2 to the k power. So you realize that you are in front the geometry sequence. Geometry sequence. What is the reason? Well, the reason, the clue, remember the formula A sub m for the geometry sequence is A1 R n minus 1. Somehow look like exponential, no? So this is exponential. But it's not clear si converges or diverges. Well, no, this is not serious. Summation, summation. And summation, you're using that formula. Summation S sub m is equal to A1 parentheses 1 minus Rm divided by 1 minus R. This is the formula. But I have no idea who is R and who is A1. There's one fantastic way to do that. I want to explain two different ways. But in my opinion, the best way is you expand a little bit this. Suppose for k equal 1, we have 2 thirds times 2 to the 1, because k is 1, is 4. 2 times 2 is 4. This is A1. Okay, this is this guy in the formula. And the second K2 is 2 thirds times 2 to the second power. This is 8, because it's 4 times 2 is 8 over 3. This is A2. And the common ratio is you divide A over 3 divided by 4 over 3. A over 3 times flip it 3 over 4. The answer is 2. Okay, therefore I have whole information. I have A1, okay, 4 thirds, I have R, K2. Do you understand this idea?
Yeah, I understand.
Another way, okay, personally, I don't like too much to understand this idea is I copy this expression. Okay, it's 2 thirds 2 to the k. But I know that my formula contains n minus 1 or k minus 1. In this case, the variable k, no? And you split that like 2 thirds times 2 to the k minus 1 times 2, no? Because 2 is just 2 and the exponent I consider is 1, and you put together negative 1 and positive 1 is cancelled, no? And you multiply, so actually is 4 thirds, I confirm that for 2 times 2 is 4, 2 to the k minus 1. So you see clear like water now, okay, that part, okay, A1 is that part. And R is this guy. K2. What way you prefer? The first one or the second?
I think the first one was easier.
Yeah. In my opinion, you are right. Now, let's move on to the formula. To say, basically, I need to find the summation of the phi term. So, in the phi. So, A1 is 4 thirds. Multiplication by 1 minus 2 to the 5th power divided by 1 minus 2 to the 5th power is 32, subtracting 1 is negative 31, and this is negative 1. The rest is calculated. 124 divided by 3 is the answer. Any question, guys? And number 12. This is find the summation, no? in the geometric sequence. This is clear? Answer me.
It's clear.
13 is similar. Summation K1 to 4 of 1/2 K plus 1. Okay, let's do it in the first way. In order to determine A1, you evaluate K1, entonces 1/2 raised to the 1 plus 1, que es 2, que 1/2 square, que es 1/4. And A2 is 1/2 raised to the 2 plus 1, que es 3, is 1/2 raised to the third power, is 1/8. So at least I know A1. And the common ratio is 1/8 divided by 1/4. Is 1/8 times 4/1 is again 4/8, que es 1/2. Okay, entonces now I discover que R is 1/2 and A1 is 1/4. Plugging in the formula. What formula? That formula. S4 is equal A1 1 minus R raised to the n power divided by 1 minus R. In our specific example, this is 1/4 1 minus 1/2 raised to the 4 power, because n is 4, divided by 1 minus 1/2. Okay, this is 16. So 1/4, 1 minus 1/16, and 1 minus 1/2 is 1/2. Entonces we have here, this is 15, no? 1/4 times 15/16, no? Because in my mind, imagination that this is 16/16, and 16 minus 1 is 15, divided by 1/2. Okay, super. And now multiplication is 1/4 times 15/16 times reciprocal, this is 2/1. We have, let me see, we have divided by 2 here, 1, divided by 2, this is 2, and the top we have 15, and the bottom we have 32. 32 is the multiplication, 2 times 16 is the answer. Clear?
It's clear.
Another possibility is, look at the expression, is 1/2 raised K plus 1. I know very well that the A sub enter of the geometric sequence A1R minus 1, ¿no? Entonces es plus 1, no minus 1. Entonces es, suppose que es 1/2. I put 1/2 twice outside, ¿no? And this is 1/2 K minus 1, because K minus 1 plus 2 is K plus 1, and this is 1/4, 1/2 raised to the K minus 1. Entonces somehow you see that the first term is 1/4, look at that, and the common ratio is 1/2. Look at that. It's another possibility. Does everyone follow me very well or no?
Yeah, I follow.
Yes.
Okay, let's move on to the 14th question. 14th question is a series. In the series, we have 5 minus 5/3 plus 5/9 plus, this is infinity, no? This is infinity. And the only possibility that this is converged is, number one, geometric series. Number two condition, common ratio, absolute value less than 1. This condition together is the only possibility to guarantee that this is convergent. I need to find convergence to what point. To determine if it's geometric or not, you divide this divided by this. It's negative 5 over 3 divided by 5. It's negative 5 over 3 times 1 over 5. The 5 is cancelled. It's negative 1. Okay, and you divide now here to verification. At least 2 is given. 5 over 9 divided by negative 5 over 3. 5 over 9 times, flip it that, is negative 3 over 5. The 5 is cancelled, the 3 is cancelled, and again we have negative 1/3. Super. Common ratio is negative 1/3. And absolute value is less than 1. Does it converge? Otherwise, no. Converge to what value? That value. S equal A1, 1 minus 1. A1 is 5. Look at that. A1 is the first. This guy. And R is negative 1/3. It says 1 minus, be careful with the sign, negative 1/3. This is 5 over 1 plus 1/3. K is 4/3. 5 over 4 over 3. Because you can interpret it like a 3 over 3. 3 plus 1 is 4. Finally flip it. 5 over 1 times 3 over 4. It's a 15 over 4. That the series converges to that value. Is it clear? Next is a little bit crazy because this was the number 14. Huh? The number 15 is 13 plus 17 plus 19 plus 21. This is arithmetic sequence. No, you're subtracting here 4. You're subtracting here is not 4, it's 2. You say no. And divide, no. You say no geometric. Si no geometric, you have infinity element. So we could diverge. So to converge it, at least empty calculus. In calculus, no. In calculus, you see another possibility. Number one, to be geometric series. And the common ratio less than 1. See, these two conditions are satisfied, then it's converged. Otherwise, no. Suppose another case, geometric series, but the common ratio is 2. No. Diverge. Okay? Let's move on to the problem of the mathematical induction. Okay, of course, only 1 and 2 easy. No big deal. Suppose proof using mathematical induction. This is question 16. This. 2 plus 8 plus, no, plus 8, no, plus 5. Plus 8 plus plus 3n minus 1 is equal n over 2 3n plus 1. And remember the basic. The basic step. Suppose que statement 1, so for n equal 1, is this guy, is true. How you prove that? Well, easy. You plug it in, this is 2, equal, and you plug it in 1 here. 1/2 3 times 1 plus 3, plus 1, sorry. 3 times 1 is 3, plus 1 is 4, and 4 divided by 2 is 2. True. Okay? You take the first and evaluate n equal 1 here. Because it's a statement 1. And the inductive step is more complicated. You assume x of k is true. Okay, how you assume that? Well, you copy exactly the same original problem. 2 plus 5 plus 8 plus plus 3k minus 1 is equal k over 2, 3k plus 1. It's super easy because the only thing you are doing is substitute n for k. However, under these assumptions, I want to investigate what happened in xk plus 1, que es the next. It says 2 plus 5 plus 8 plus plus 3k minus 1 plus I included 3k plus 1 minus 1. Let me try to manipulate this separately here. 3 paréntesis k plus 1 minus 1 is 3k plus 3 minus 1 is 3k plus 2. Okay, good. So no, there are no reason to write in that way. It's complicated. No. Much better is 3k plus 2. Equal, in the right hand side we have k plus 1 divided by 2, 3k plus 1, parenthesis plus 1. Again. Let me try to manipulate this to understand more clear. This is 3 parenthesis k plus 1 plus 1. Distributing 3k plus 3 plus 1. 3k plus 1. Okay, so you replace this expression by parenthesis 3k plus 1. So far, so good? Now, so you consider that this is true. Okay, what's the first idea in the inductive step? You can replace this expression for this. Okay, it's k over 2, 3k plus 1, plus 3k plus 2. Now, for the moment, I don't touch this. I manipulate the left-hand side. Entonces hay condensing, I have only one denominator, entonces I assume que the least common denominator is 2, no? We have k, 3k plus 1, plus 2 times 3k plus 2. Okay, now, bueno, expand that. Distribute here, 3k squared plus k. Plus, distribute here, 6k plus 4 divided by 2. Okay, we combine like term, 3k squared plus 7k plus 4 over 2. And for a moment, leave it like that, for a moment. Let me try now, manipulate a little bit that part. These two I consider like a common denominator because actually it's multiplication, and you FOIL. And when you FOIL, you have 3k squared plus 4k plus 3k, que is 1 times 3 plus 4. And one more time, we combine later. 3k squared plus 7k plus 4 divided by 2. Boom. Same. Proof. 1, 2, and 3. Any question? ¿Es easy o complicated?
It's a bit complicated, but I understand it.
No. What part is complicated? I want to discuss it. This is the review. Please let me know. I explain in different time until you feel comfortable. Okay, you understand this. What part is complicated? Okay. Do you understand that part?
Where you put green?
Uh-huh.
Yes, I understand it.
No problem. Do you understand that part?
Yes, it's the next part that got me a bit confused.
Okay.
Okay, how you crunched it all down together.
Look, the only thing I did was, under the supposition que this part is true, I replace this for this. So I delete that part, do not exist. Yeah, I copy this. This and
Okay, I
this.
understand.
The rest is algebra, elementary. Intermediate. Yeah. Clear?
Yes.
Entonces I explain in the lecture que si you consider que one piece of the domino K is true, fail, and the other, this implies que the next, que es K plus 1, fail, entonces this process continues forever. So you don't need to prove using infinity possibility that we cannot do. It's impossible, no? Okay?
I got it.
Okay, let's move on to the binomial. Teorema que es easy. Super easy. The formula for the binomial, remember, is a plus b to the n power is equal to summation from k0 to m of the combinatory number nk, a n minus k, bk. That's the formula for the Newton. In this case, they want you expand in the question number 17. You expand this binomial 2x plus 3 to the fifth power. You consider que a is 2x, and you consider que b is 3. And also, to find the coefficients, we can do using the combinatory number in the calculator or the Pascal. The Pascal is useful when you have not too much. It's fine, it's possible to do it by hand. Okay, this is the coefficients. Okay, so expand this. Remember, is 8 to the fifth power. That you copy. Well, the first combinatory number is 1. This is the row I need. This is 1. And you have 8, que a in our specific question is 2x to the fifth power. Okay, and no b, because b is 0. B is 3 to the 0 power. The next is 5, okay, this number. And we have 2x to the 4 power. And we have big is 3 to the 1 power. And always you checking just in case 4 plus 1 is 5, exactly like this. Any term, the summation for the exponent is 5. What's the next thing? 2x to the third power and 3 to the second power. 3 plus 2, 5. And 10 is that number. What's the next? 10 again. 2x to the second power, you decreasing the exponent for the a, and you increasing the exponent for the b. Is 3 to the given power. Plus 5, 2x to the 1 power, is invisible. 3 to the 4 power, plus 1, is the last coefficient, exactly the same of the first one, is 3 to the 5th power. Do you understand this? Everyone follow me?
Yeah.
I understand.
Okay, now, of course, no, don't leave it like that. It's crazy, no? So you solving one by one. 2 to the 5th power is 32. 32 x to the 5th power. This is 2 to the 4 power get 16. 16 times 3 and times 5. The answer is 240. 240 x to the 4 power. Great. Do you follow me? Do you understand where I come from? 240? 240?
Yes.
Plus. This is 10. This is 8. 2 to the 3rd power. And this is 9. 9. 8 times 9 is 72. And 72 times 10 is 720. X cubic. Plus, you say when you don't understand something, guys, and this is 2 to the 2nd power is 4. This is 3 to the 3rd power is 27, and 27 times 4 times 10 is 1080. X to the 2nd power, get the power of the x. Plus 5 times 2 is 10. And 3 to the 4th power is 81. 81 times 10 is 810. 1x only. Plus 3 to the 5th power is 243. End the story. This is the final answer. Boom. Any question? It's clear, right? Because we practiced a little bit in the lecture. But no.
Yes, it's clear.
And we're reinforcing now, you know? Okay, so now the next, que es 18, is very, very similar, but this is to the 6th power. So I take advantage de Pascal, including one extra row, que es 6, 15, 20, 15, 15, 6, and 1. This is for N6. This is for M5. So in 18, the coefficients are, okay, it's 18. 18. 18 is W minus S to the 6th power. Be careful because it's negative. And the formula for the Newton, no consider the negative. The idea is clear que es positive, but it's easy. You define que W is A and B is negative, right? And that's it. The first guy is 1. Look here, 1. But it's W6. And no S. The next is plus 6. Look at that coefficient. W5 and minus S to the 1 power. Remember, it's 1 invisible because 1 plus 5 is 6, no? For a moment, leave it like that. After we simplification, only set up like that. Plus 15. Get the next number. W4 and minus X squared. 4 plus 2 is 6. Plus 20. Plus 20. W3 minus X to the 3rd power. Let me continue down. What is the next number? We did that. 15 again. Repetition. 15. W squared. Remember this. 6, 5, 4, 3, 2. And minus X to the 4th power. Plus, almost we finish 6. W to the 1 power. And minus X to the 5th power. Finally, X to the 6th power. Actually, it's minus, ¿no? Pero the exponent is even, entonces become positive. Okay, entonces now when you have minus, you can see the idea clear, que es alternating, positive, negative, positive, negative, positive, negative. The first guy is W6 minus 6 times W5 S, because this negative and this positive become negative. But this no, because it's a square, entonces any even power is positive. Entonces plus 15 W4 S squared. Minus, now minus because the exponent is odd number. 20, W3, S3. Plus, because the exponent is positive. 15, W squared, S to the 4th power. Minus, because the exponent is odd number. 6W, S to the 5th power. And finally, plus again, X to the 6th. And this is my final answer. Any question? Guys, this is very, very important. Okay, you know en calculus. Okay, binomial theorem. Binomial theorem. Okay. The question 19 and 20 is not, it's the same topic, but it's not expand completed the binomials. No, you discover specifically one term. So I suppose the question, okay. Okay. And the question 19, I want, can you find only one guy in the expansion? The expansion of what? Of the one binomial is 9x plus 6 to the cubic power. It's easy. Okay, however, I don't need to expand. You can, in this case, it's easy because actually x to the cubic contain only 4 terms. You can do, if you want, I do, we double checking, no? But no. So basically, they want to know when the term can contain x alone, x to the 1 power. Entonces ahí será the formula of the Newton. The Newton say es combinatorio number nk, a minus k, bk. Pero en our example is 3. K, I have no idea. Because the only information they have is the exponent. I know that A is 9x. So you replace, no A anymore. No. Is 9x. Raised to the one exponent, que es 9 minus k, 3 minus k, sorry. 3 minus k, and B es 6. Entonces, 6 to the k. Es obvio que the only part que contain x es that part. And the exponent day 1 que es 1. Entonces es similar to say que 3 minus k es equal 1. Es obvio que es esto. Entonces basically to find the specific, you put now combinatory number 3 to 9x raised to the 1 power, because I artificially created this 1, and this is 6 squared. Okay. And combinatory number 32 is doing using the formula for the combinatory to make sure 3 factorial divided by 2 factorial, 3 minus 2 factorial. 3 minus 2 factorial is 1. And 1 factorial is 1. That guy is 1. And this is 3 times 2 factorial divided by 2 factorial. It's obvious that the answer is 3. The combinatory number is 3. It's obvious. And the Pascal triangle, look, is 1, 1, 2, 1, 1, 3, 3, 1. And we are talking about k equal 2. And k equal 2 is these coefficients. Because this is K0, this is K1, and this is K2, and this is K3. Entonces es obvio que es 3 es the coefficient. So this is no surprise. This is 3, 9x, and 36. And you multiply each other, 972x is the answer. Super good or super bad? Any question? Any question? No? Okay, let's do it the last one, 20. 20, 20, 20. 20 is a little bit more complicated. No, you have the binomial case x plus 3y raised to the 10th power. I need to find the ninth term. Actually, we have 11, no? Because it's 10 plus 1. But in the position 9 is the term that I want to find. And you need to know that when you're talking about 9 position, it's K8. Because you start counting at 0, 0, 0, 1. 1 is 2, so 1 more. Do you understand this idea clear or not? So when you expand this guy, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11 turn. However, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. I like that guy. I want that guy. And this is 10 and this is 11. Okay, but K is 0, 1. This is K. 2, 3, 4, 5, 6, 7, and 8. That's super easy. Memorize que the position 9 or the position M, K is equal to M minus 1. So you subtract 1. And then the story. That's it. Okay, now I can see in the formula the binomial A is X and B is 3Y. So we have combinatory number 10 to 8 because N is 10, K is 8. We have X, que is 8, raised to the N minus K, que es 10 minus 8, que es 2. And B is 3Y, raised to the K power, que es 8. Boom. Okay. You find combinatory number by hand or calculator. I don't know if I explained by calculator the last time. I explained or no? Never. Okay, is the key.
No, I don't think you did.
No. The problem is that depending of the calculator, no? The typical calculator, we have one key that is called a PRB. Do you see you have your calculator in this moment with you or no? Okay, words to explain this or no? PRB.
I have it on my calculator.
Do you have your calculator? What is your calculator, mister?
TI 30X 2S, I think it is.
Exactly. Do you see the key PRB?
Yeah.
Press this. When you press this PRB, you see something like that in the display. Let me try to do my best. NPR, NCR, and factorial. Do you see that?
Yes.
Okay, now you moving the arrow key to navigate inside this menu until you select this. You see?
You select NPR?
You select NCR, que es combinatorio.
Okay.
Combinatorio, no PCR. This is another. NCR. And when you press enter, you see NCR. Answer NCR. But what is the problem? The problem is, okay, please clear everything in your display. Clear. We start. It's basically combinatory number 10, combinatory number 8. It's the thing that I want to calculate here, right? So you press 10 first. You press PRB key. Select combinatory, press equal, and you put 8 and you press enter and you have 45. You see 45?
Yes.
The student can have no calculator, but you know, to take calculator, you need calculator and sophisticated calculator. By hand is, guys, it's no merit in this level of the mathematical, the arithmetic computation. I suppose everyone knows that, and this is what's the time, in my opinion. But okay. Suppose 10 factorial is 10 times 9 times 8 factorial. Expanded to 8 because I know in the denominator we have 8 factorial and 10 minus 8 factorial. It's obvious that that part is cancelled. And 10 minus 8 factorial is 2 factorial. And 2 factorial is 2 times 1 is 2. And 10 times 9 is 90. And 90 divided by 2 is 45. You understand this?
Yes.
Okay, so that combinatory number is 45. And this is x squared, correct? 10 minus 8 is 2. And we have 3 to the a power, y to the a power. And 3 to the a power is, put in my calculator also, is 6,561. So what is my final answer? When you multiply 6,561 times 45, and the answer is 29,295. Actually, is 295,245. It's a 5. X squared, y to the a power. That is the final answer. Do you understand very well the idea for the binomial? I suppose in the test, I don't see no complicated, I see easy problem. Similar to the review package. Okay, so now we stop, that's it. Now I sent, remember, what is my last part of the semester? Okay, let me start sharing. Do you see my face? Listen.
Yes.
Next Tuesday. It's 26, right? Let me check in the calendar. Okay. I need to receive your answer in the test number 4 on paper. You send me by email. I will grade that next day, so Wednesday. This day, next Tuesday, I will send the final test. Remember, final is optional. Only if you want to improve. It's super easy to compute the overall grade. We have in total 8 tests, plus the extra credit que you community throughout the semester, no? Entonces you adding 8 tests, 4 and 4, online and on paper together, boom, divided by 8, average, and this is your overall grade. And if you consider that you need to improve, take the final, and the final is due next week, is April 28th. It's next Thursday. And in the story, we have no more. At 26, I open the lectures, but I don't need to explain anything. I open only the student can explain again one example of the review. Okay, no problem. I explain. And that's it. 28, I don't open anymore. Don't send any other email. I only receive by email the final test. There are no final tests online, only on paper. Okay? And don't forget also, I forgot, but I want to repeat, April 26, you submit the homework and the test number 4 online. Clear or confusing? Let me know.
It's clear.
It's
Okay.
clear.
So you see, remember the last day is next Tuesday, and that's it. We finish successfully, I suppose. Please, you check in the blackboard. Any discrepancy you see in the blackboard and the grade, you communicate with me by email. I check in, see you are right. I fix it, see you are wrong. No, stay the same. Okay? Okay? Okay?
Okay.
Bye.
Bye. Have a good day.
Have a good day,
Bye.
Professor.
Thank you,
Thank you,
Professor.
Bye, Professor.